Okay, so we're going to look at the sine law. Up until now, you've been using trig in right-angled triangles. So there are two laws that we're going to learn that will help us with oblique triangles. So triangles that don't have a 90-degree angle in it. And the first one is the sine law, and then we'll learn the cosine law as well. There isn't really a tan law, so there's one for each of sine and cos. So here's an example of an oblique triangle. That kind of looks at A might be 90, but it's not. And certainly we haven't been told that it is. Even we can use the sine law in 90-degree triangles, but it's a little bit more work. So if you have a 90-degree triangle, just use your regular trig ratios. In any case, this is the sine law. You can show it in this form with the sides in the numerator and the sine of the angles in the denominators, or reciprocals. Okay, take a look. There's no adding or subtracting. This is really equals here. So anytime that we're going to use the sine law, we're going to split it into just that part, or just that part, or between A's and C's. Okay, you're never using this all at once. So that's the sine law. We want to basically look at why it's true. Okay, so develop it. So I'm just going to change here. So here's the oblique triangle. Vertices are usually capital letters if we're using letters. And so opposite those capital letters, the sides are lowercase. So sometimes you'll be just given angles and asked for side C. And you have to know that side C is opposite angle C. Side B is opposite angle B. Side A is opposite angle A. In any case, in order to relate this back to right triangles, which we do know, we draw a vertical line here compared to the base. It doesn't have to be on this side. It could be any side, but it just kind of makes sense to do it this way with a little 90 degrees, so we know it's vertical. So that's cut this big triangle into two 90-degree triangles. So take a look in triangle ABD, that's the left one. Sine of B, so this angle here is opposite, which is H. H isn't hypotenuse, H is the height. So opposite over the hypotenuse C, H over C. So if we solve for H here, we get C sine of capital B. Okay, let's do the same in the other triangle. So sine of C would be H over B. If we solve for H, then we multiply sine by B. So B sine capital C. Okay, well, in these two triangles, that height is the same. So this H here has to be equal to this H. So that means C sine B has to equal little b sine big C. So that, in a sense, is the sine law. We don't tend to show it like that. What we end up doing is dividing both sides by sine B, sine C. So basically trying to get the lowercase letters by themselves in the numerators. So I'll go back and do that just up here. So sine B sine C, and then over here sine B sine C. Okay, and so when you do that, these divide out and these divide out. Okay, and so what you are left with here, I'll change back to blue, is lowercase c over sine of uppercase C equals lowercase b over sine of uppercase B. Okay, so that is the first part of the sine law. Well, actually, not the first part. If you take a look back, B's and C's, that's the second part here, the second circle that I have. Okay, and so that's how we can get that relationship. If we were to then draw the altitude from C and use similar steps, so if we went and did a line here, okay, and split it into two triangles, then we would get this relationship. Or we could do it the other side as well and get a relationship between A and C. In any case, we can put them all together. There's your sine law. Okay, and so anytime we're using this, we're going to end up choosing two of these ratios, because then it's a proportion question basically that we can solve. So that's what we're going to do. As well, you can flip all of them because there's no adding in here, right? So these are all ratios. So as long as you take the reciprocal of the first one, then you have to do it for the second and the third. And that is helpful if you're looking for an unknown that's an angle. Okay, so summarized here. So to use the sine law to determine missing side, we'll use A over sine A equals B over sine B. This is what you need to know. You need to know a side and its opposite angle, as well as the angle opposite the unknown. So taking a look here, these are known. So I always try to do a little cross. Okay. If I have the cross where one is filled in, so this one is, I know both, and this I have, but I'm looking for this, then I can use the sine law. Okay, if I can't do that cross, I can't use the sine law. Maybe there's some other work that I could do and then do the sine law, but right away I can't use it. Okay, so that's for finding a missing side. And then kind of similar for a missing angle, have to know one complete pair. I call it a pair. So something that satisfies one of the ratios. And then I have to know one of the other. Okay, so this has to match up. If I want to know angle B, I have to know side B. Okay, so I have to be able to do that crisscross. So then here, I know this, so I know all three of these and just one unknown. Okay, so let's practice. So solve for x rounded to the nearest hundredth. So I do my little cross here, and we're good for the sine law because I know a complete pair here and one of the others. And I'm looking for x. I'm not going to use A, B, C's, and D's. I'm looking for a side, so that's x, and the angle opposite it is 50. So now sine 50. So I don't even put A's, B's, C's, and D's. There aren't any D's, I guess. Okay, and then the side. So always match these up. If you've got the side in the numerator, this side has to be in the numerator. Okay, so now to get x by itself, all right, fastest way, I'm not going to multiply by the common denominator because then I'd have to do two steps. There's nothing multiplied by x, so the easiest thing is just to multiply both sides by sine 50. I mean, yeah, you can cross multiply, but then you do have to divide. So in this case, just multiply both sides by sine 50. So those divide out. Okay, and so then I'm left with x equals, so this is what it looks like, 10 sine 50 degrees over sine 70 degrees. Okay, so get your calculator out. Okay, turn it on, check your mode key. Is it in degree mode? If it isn't, then go down to degree and select it. Quit over out of that. I find the fastest way, this is 10 times sine of 50 divided by sine 70. You can, dividing by the whole thing by sine 70 is like dividing at the end. So you can just go 10 sine 50. As long as you close the brackets on sine 50, you can then go divide sine 70. Okay, this does not simplify to sine of 50 over 70. This is a separate value. Okay, so you can do it like that. If you have the fraction capability, you can set it up as a fraction. Go 10 sine 50 and then in the denominator, sine of 70. Okay, you get the same thing. And this is a final answer. We're not using it anywhere else. So now I can round. It asks for the nearest hundredth, 1/5. Okay, it doesn't have units, so you can just put the word units. All right. Okay, next one. This one doesn't give you a triangle. It gives you some properties, so you're going to want to draw your triangle. So it gives you an angle. So I often start with a side and form that angle just sort of horizontal from the horizontal. So 60 would be something like that, I would think. Okay. Now angle, so this would be P. Angle O is 25. So I'm going to put O here also with that horizontal. So I'm going to spread that out a little bit so that when I join these up, it looks a little bit more like 25. Okay, so let me label here. So this would be my P, and that's 63. This would be my O, and that's 25. A little thing, but it doesn't really matter. So I don't know what this one is. It's called POR, so this would have to be my R. Okay, and that means lowercase r is opposite the angle R, so that's going to be 12 centimeters. So I've labeled everything that's given to me, and it says determine the perimeter. So I'm going to have to find the other two sides. So this is, it's kind of almost like solving a triangle where you have to find all the angles and all the sides. Now, taking a look at this, I want to if I know this side, I need to know this angle here, right? Because if I'm really wanting to calculate, so I'm going to call this lowercase p, and I'm just going to use, I don't like using O, so I don't know why we used O. Let's change this to Q. That's, I think, what we should have used. Because O looks like 0, right? So we're going to call this Q. And so then this is lowercase q. In any case, we don't know this angle, so we can't use the sine law yet. So take a look at your triangle. Is there a way of getting that angle? Well, we are given two of the angles in a triangle. So that means we can calculate R just by subtracting from 180. So I'm going to do that first. So R equals 180 minus 25 minus 63. Okay, so 180 minus 25 minus 63 is 92. All right, so now this is 92, and we have one pair there, and I'm going to start with P. There's my other pair. So I'm trying to find P. So P is over the sine of the angle opposite it, which is 63. And I know the side 12, and it is opposite 92, so that's over sine of 92. So now P equals, when we multiply through by sine of 63, it's going to be in the numerator on the other side. Okay. And get out your calculator. Move that a little bit. Yeah. Okay, and I'm going to go 12 sine 63 divided by sine of 92. Okay, and that's 10. Now, this is not my final answer, so I'm going to keep 3 decimal places. Because it says round your final answer to the nearest tenth, so I like to go 2 more decimal places. So 699, Now it is on your calculator, but this is a backup in case you clear your calculator, you lose the value or something like that. Then to get Q, so now Q over this angle opposite is 25, so that's going to be sine of 25 degrees. And I use the same pair, the 12 over sine of 92. Now you could use 10.699 over sine of 63, but that's rounded. If you kept it in your calculator, you could use it. I tend to go back to anything that the more unrounded values, the better. Okay, so now to get Q by itself, I multiply through by sine of 25, so that's going to be 12 sine of 25 over sine of 92. Okay, and now when I do this, I'm going to have 12 sine 25, close the bracket, divided by sine of 92, close the bracket, 5.075. Okay, and so the perimeter, I'm not going to use P because it's used as a vertex. Perimeter, sorry, I'm using my mouse, so my writing is not great, is going to be, don't forget the 12, plus 10.699 plus 5.075. Now, if you have the ability in your calculator to go back, so basically if I press plus right now, that's taking 5.07, etc., adding, so if I can go back to my other side, some of you will have that capability, some of you won't. So if you don't, then just go answer plus, so that it'll just, when you press plus, it gives that as the answer. Then put in your 3-digit rounding, and then add your 12. And then 27.773. And then round that to the nearest tenth. So that's going to be 27.8. And again, it didn't give, oh, it did give units, so it's centimeters. Now what you could do as well is you could go right away perimeter 12 plus, and in your calculator put this plus and then put this, okay, to get it all in there rather than doing it separately like I did. Okay, but that's basically solving a triangle, because we had to find every angle and every side, and then calculating the perimeter. Okay, next one, solve the triangle, rounding final answers to the nearest tenth. So I just talked about that in the last question. To solve a triangle, remember, means to find all the sides and all the angles. So right now we have two sides and an angle, and so again I like to match up. So I've got a pair there, which means I can find this angle A in using the sine law in the first step. So remember that if you're solving for angle A, you might want to use the second version of the sine law, where everything is, the reciprocal is taken for every fraction in it. So that would be sine A over the side opposite, which is 5. And then the angle we do know is C, so that would be 50 degrees over the side opposite, which is 8. Okay, and then if we're solving for A here, really what we're going to do, we haven't done one of these yet, so is multiply through by 5, so that divides out. So then you really get, you don't have to show that multiplying through by 5, but do show sine A and what it's equal to. So that 5 that's multiplied is not multiplying the angle, so I'm going to show it in front. especially if your writing is a little bit untidy, which mine is right now because I'm using a mouse for this. Okay, so that's a monomial, constant monomial of 5 multiplied by sine of 50. Divide by 8. So then calculator, so 5 sine of 50, close the brackets, and then you can divide by 8. Okay, or you could do, if you have the ability to do a fraction, you can go 5 sine 50, then denominator is 8. Okay, and so that is the value of the ratio. So now, again, you have a choice here. I'm going to write it out to actually quite a few decimal places, and this is just sort of for safety reasons, in case you clear your calculator or something. So 478, so 0.478, and then there's a bunch of 7s. So I'll go, that's 3, 4, and then I'll round to the nearest fifth decimal place. And so A will be inverse sine of that. Okay. Now, what might be better to get it all done in one step is go back up from this step to here and go second key, sine key, and then punch in that ratio. Okay, and then everything's done in one step in your calculator. That's part of the reason why you have this TI or Casio graphing calculator. It'll do a lot of things for you. So now second sine. So if I use the ratio that I've already calculated, then I can just copy that answer out, close the brackets. There's my angle. If I do it right from this step, then it's second sine, and then I'd go 5 sine 50. You can do the fraction if you want. Close the brackets, divide by 8, then close the sine, inverse sine brackets, and you get the same thing. Okay, so it says round to the nearest tenth. I'm going to, again, show a couple of decimal places. So 328.606. And then round to the nearest tenth would be that. Okay, so that's angle A. Now, to get angle B, we just subtract, right? So we already have this being 50, so angle B, equals 180 minus 50 minus 28.6. And because none of these were rounded answers, they were all given, you can use the rounded here. It's not going to cause a problem. If these were rounded, I would actually keep the 3 decimal places. Okay, so kind of up to you. I'll leave it there because I've just written it in, but in your calculator you already have that, so you can go 180 minus 50 and minus that answer. And now this is the last angle, so we don't have to copy more decimal places, just round to the nearest tenth, which is 101.4. Okay. Now saying that, maybe we need to use, so here we need to use angle B in our calculation for side B. So I'm actually going to go back and put 394 in there, and then round it. So 394, and then my final answer 101.4 with a degree symbol. Okay, so we've got all the angles. Now we need to get that side B here. Okay, so this is lowercase b. So matching that up, we need to know this angle, which we just calculated. Okay, and we have this ratio. I wouldn't use this other ratio because it's also a calculated value. Use whatever you have that is given to you if you can. Now we're looking for a side, so the b is going to be in the numerator here, and then it's going to be over sine of 101.394. Now that way, I've kept some decimal places. Now we can probably on our calculator go back and use the more decimal places, but at least we have 3 there, and that's why I kept it. And then the ratio we do know is 8 over sine of 50. Okay, so if we are solving for b, we're going to multiply through by sine of 101. Okay, over sine of 50. 3 decimal places, if you use that, should be fine for this triangle. If you get triangles with really big sides to them, then you want to use more decimal places. Okay, so in our calculator, let's see. We're going to go 8 and then sine of 101.394, etc. That's my last answer. So we can all do that in our calculator because that's second negative, gives you the previous answer. Okay, and then divide by sine of 50. Okay, and this is the final thing that we have to calculate. So I'm not going to copy out 3 decimal places. I'm just going to go to 1 as it asks. And there were no units given, so you can just put the word units. Okay. So that one we had to solve means to find all of the missing information. If you could go back, it would be nice if you could go, actually I'll do this, B. If you could go back and either rewrite everything or put a box around everything. So this is B. Okay. Everything that you calculated. All right, so that is question 3. And then this one says determine the area of the triangle, round to the nearest tenth. So area is base times height divided by 2. So if we use the horizontal as our base, we have the base. Now what we want to do is we need to find the height. Okay, so I'm going to call that h for height, not for hypotenuse. Now, we only have one side. We could find this angle here, but you know, what does that give us? It still doesn't give us this side in here. If we look at this individual triangle, we have an angle, but we don't have this actual distance here, right? Because the whole thing is 10. So this is for the whole thing is 10. Okay, we don't have this side, we don't have this side. So what we want to do is, if we can find the length of this side, then we can use our regular trig, opposite over hypotenuse, and find the value of the height. Okay, so in order to get this side, that's in an oblique triangle, we want to use sine law. So that is your matchup. Now here, we need a complete matchup. Okay, so we don't know this angle, but the good news is that we know the other two. So this angle in here, maybe I'll do it in red, is going to be 180 minus 70 minus 30. Okay, and so that's going to be 80 degrees. So that's going to be our matchup, our pair that we do know. So we want to find x, it's opposite 70, so that's over sine 70. And 10 is opposite 80, so that's sine 80. Okay, so x equals 10 sine 70 over sine 80. So grab your calculator. That's 10 sine 70 divided by sine 80. Okay, and so that's 9.5. Okay, so this is where for sure you want to keep a few decimal places. So 542 for sure. I may even go more than that, actually, because I know I'm multiplying through by 10. So no, I think 3 is fine if we're rounding. So always go at least 2 more decimal places than what you're asked to round to at the end. Okay, so that's our x. Now we're going to use just regular trig because that's a 90-degree triangle in there. So sine of 30 is the height of the triangle over 9.542. So I do this in separate steps. I mean, you could put this all into that denominator here. So when you multiply through, you could just multiply that ratio here by sine of 30. Depends how comfortable you feel. I do it in steps, especially with a graphing calculator that keeps decimal places. So now my height here, if I get my calculator out, I still have that previous calculation. Don't re-enter it as this because this is better. It's in there. And then just press times sine of 30. Okay, and now our height is 4.771 to 3 decimal places. Okay, no units yet. We're not done yet. Now we calculate the area of a triangle is base times height divided by 2. So our base is 10. Our height is 4.771 and divide by 2. And again, in your calculator, you already have that. Keep it. Use it. Now multiply that by 10. Order of multiplying doesn't matter. And then divide by 2. Okay, so 23.855. And now, nearest tenth is going to be 23.9. And that's centimeters squared. Okay, so sometimes in order to calculate the area of an oblique triangle, you need the height, right? And if you don't have it, you need to work around it. So how we did that was we found another side of the triangle. I could have found this side instead, but I found this, and then I used sine in that triangle. Okay. Okay, and then this one, we've got 2 right triangles, a big outside one and an inside one. So we kind of looked at this type of question yesterday, I guess it was, in our double triangle questions. But notice what the information is given. We're not given an actual side of either of those triangles. We're given this distance here, which is really a side of this oblique triangle. Okay, so if we were to use just right angle triangle, we'd actually have to do 2 equations. We'd have to solve the system. There would be 2 unknowns, and it would be a little bit, it's a bit challenging. But now that we know the sine law, that can help us. So looking at this oblique triangle here, we only have 1 angle, but the good news is this is a straight line. So we can calculate this angle. That'll be 180 minus 60 is 120. Okay, so then this angle in here will be 180 minus 120 minus 20. So that's going to be 40. And then in here, if we need this one, this angle here would be 30, because that's a 90-degree triangle. Okay, so now look at what we have. We have this side of this oblique triangle. So, and we know the angle opposite it. So you can kind of do your pair there. And then this angle here, I could calculate this side. I'm not going to call it x because that's already x. So let me call it y. Okay. If I calculate y, then I know this angle here. Okay. Or I know this angle here. And I will have a whole side of the triangle. So if I have a whole side and an angle, I can find another side. So that's what I'm going to do. So there's a few different variations, but this is the one that I'm going to do. Now, I'll talk about the variations in a sec, but this is the one. So I'm going to go y over sine of 120 equals 10 over sine of 40. So y equals 10 sine of 120 over sine of 40. Okay, and calculator out. That's going to be, oops, I'm going to, sorry. There. Oh, I'm so sorry. I'm trying to there. Oh my gosh. Okay, maybe I'll just leave it like that. Now I've forgotten. It is 10 sine 120. Okay, so I'm going to start here. 10 sine of 120, close the brackets, divide by sine of 40. Okay, and that's 13.473. So 13.473. Again, a few more decimal places than what we're given. So that's your y value. Now, you have a choice. So if I use this complete angle, that's 70, or you might want to use 20. 20 is already given to you. Then you don't even have to add 30 and 40. So in this case, then we would use sine of 20 equals x over our y value, 13.473. So x is that value, sine 20. Okay, so what's great is you have that 13.473, all those decimal places, so just press times sine of 20, and you get 4.608, which rounds to 4.6. And this is in meters. Okay. And that's it. That's all you had to do. If you wanted to, you could have found, I'll call this Z. Oh, maybe I'll do it in green here. So if I found this green Z, then I would have had Z over sine of 20 equals 10 over sine 40. Okay, and then you'd figure out what Z is. And then in this triangle, I'd probably use 60 degrees. So then sine of 60 degrees equals x over whatever your Z value is. Okay, and you get the same thing. So that's it.